Bismillahirrahmanirrahim. I am Abid Rida Babil from Yambo Industrial College and teaching you General Chemistry GSCH 101. Our module number 1 is atoms, molecules and ions. In this module we will study lot of things. First of all, we start with the atoms. Atoms are the smallest particle of the element. An atom contains 3 subatomic particles: electron, proton and neutron. The electrons, the mass of the electron is given in gram here, that is for your information, but we will use the mass in unit mass. For us, the mass of the electron is almost 0 and mass of the proton is 1. Similarly, mass of the neutron is also 1. And same, the charge of the electron, proton and neutron are given in the coulombs, and that is for your information. But what we will use, you will use the unit charge. So mass charge of the electron is -1 here, this one the -1, and charge of the proton is +1 and charge of the neutron is 0. So this is the basic information about the atom that you will need to understand the atomic number, mass number and isotopes. So first of all, we see the atomic number. Atomic numbers are just the number of proton. This you have to see in the periodic table or in the question. The number of proton is actually the atomic number, and the mass number is the total of protons plus neutron. And similarly, we can say instead of proton we can say atomic number. So mass number will be equal to atomic number plus number of neutrons. So you can say either way, whatever you understand. And the number of neutron can be calculated by the same formula, that is number of neutron is equal to mass number minus number of proton. That will give you the number of neutrons. Isotopes I will teach you later, but first let us know how to write the symbol of an element with the atomic number and mass number. When you write the symbol by your hand, this will be the way. This X means the symbol of the element, and on the left superscript in place of A it is represented by the mass number, and on the left subscript in place of Z we write the atomic number. Here you have to say something, that this is your periodic table, and this also gives the information about the atomic number and mass number. You see here in the periodic table, this is the explanation here for one example of mercury. The atomic number is on the top of the symbol, but here the atomic number is at the subscript and the left side of the symbol. So this is the difference. These are the rules of the chemistry. Okay, and mass number is given here at the bottom of the symbol, but the mass number is given as a superscript on the left side of the symbol. Okay, so this is the difference between what you see in the periodic table and what you write by your hand. There is a little bit difference. And there is one more information. Sometime charge is given. So charge sometime is positive, or maybe sometime it will be negative. That will be the ion. So this charge is written on the right superscript of the symbol, that you will also see in just few minutes. So this is the information how to write the mass number and the atomic number and the charge on a symbol. So now let's come again to the isotopes. Isotopes are the atoms of the same element with the same atomic number but different mass number. So let me tell you one information, that in an atom there are 3 particles: proton, electrons and neutron. You cannot change the number of proton. The number of proton will remain the same. If you change by some way the number of proton, the element itself will change. See the example here. In hydrogen there is 1 proton. If you make it 2 proton, it become helium atom. If you make 3 proton, then it become lithium element, and if you make 4 proton, then it will be beryllium atom. So by changing the number of proton, you change the number of atomic number, means you change the actual element. That is almost impossible. But what we change, the nature has changed the number of neutrons. By changing the number of neutrons, we say it is isotopes. So number of proton will remain same, as you see here. In this case, this is the at here subscript, this is the atomic number, this 1, this also 1, and this also 1. Let me show you more clearly by writing it. This is 1, and this is also 1, and this is also 1. Means atomic number is same, number of proton is not changing, but the mass number is changing. This 1 changed to 2, means 1 neutron is added here, and then change to 3, means 2 neutrons are added here. See the diagram here, that will give you more detailed picture of isotopes of hydrogen. In this, here is 1 proton only, no neutron, so mass number is 1 and the atomic number is also 1. Here we have 1 proton, so atomic number is remaining same, 1, but 1 neutron is additional, so mass number will be 2. And in the tritium, actually this is the name, tritium of this isotope, 1 proton and 2 additional neutrons are there, so total 3, so mass number will be the 3. So protium with the proton 1 and the neutron 0 and electron 1 is called protium. Deuterium have 1 proton, 1 neutron, and electron remains same 1. In the tritium, 1 proton and 2 neutron. So these are the 3 isotopes of hydrogen atom. And there is another example here of uranium, very famous element uranium. The atomic number remain the same, that is 92 and 92, but the mass number is changing from 235 to 238, means 3 neutrons are further added in the uranium 238. So this is the way to see the atomic number, mass number, and to understand how to calculate the number of neutron and how to say this is the isotope of an element. Now when you change the electron, when you change the number of electron, then it become ion. There are 2 types of ions, anion and cation. When the electron are removed or lost from the element or the atom, then it becomes cation. For example, sodium have 11 electron. When we remove 1 electron, it becomes 10, so 1 positive charge will occur here, so this becomes cation, sodium positive ion. And while the anions, electrons are gained or added in the atom, so here it is 17 electrons that is changed to 18, means 1 electron is added, so chlorine become chloride, 1 negative ion, this is anion. If you see, this is the size of the chloride is bigger than the neutral atom. And sodium also, this is neutral because the number of proton and number of electron are equal, so there is no charge here, but when an electron is lost, it left behind a positive charge, so it becomes cation. Cation is smaller than the neutral atom. So this is the example of cation and anion. And now these are some types of the ions. Monoatomic, mono is 1, so in this case the sodium atom and 1 positive charge, this is called sodium cation, and it have this. And second example, chlorine, 1 atom, single atom and 1 negative charge, so this is called chloride. Calcium, single atom and 2 positive charge, it is called calcium ion. Oxygen, single atom here with 2 negative charge, it is called oxide. Aluminium with 3 positive charge, it is also single atom, so it is aluminium cation. And nitrogen, single atom with 3 negative charge, is called nitroid. So there will be many more examples. At the end of this module, you have to learn some of the names of these cations and anions also. So see the polyatomic are ions with more than 1 atoms. So like this example, oxygen and hydrogen, this make hydroxide with 1 negative charge. Carbon and nitrogen make cyanide with 1 negative charge. 1 nitrogen and 4 hydrogen make ammonium ion with positive charge, means it is cation. And 1 nitrogen and 3 oxygen atom makes nitrate ion with 1 negative charge. So these are the example, and you can see further examples at the end of this module. Now again come back to calculate the number of proton, neutrons and the electron. Here you see this is aluminum atom, and we have to know how many protons are there. So this is the atomic number. So this atomic number is same as the number of proton. This will be the same. And How to calculate the number of electrons? So just we have said to subtract, this is total number of proton, that in the neutral atom it will be equal, but because here it is 3 positive charge, means you have to say 13 minus 3 is equal to 10 electron. To calculate the number of neutron, it is very easy. Just mass number minus this number of proton, or the atomic number, means 27 minus 13 will give you the 14 number of neutron. So another example for you, the selenium atom. In the selenium, again we have this 34 is the atomic number. This atomic number is exactly equal to the number of proton, and to calculate the number of electron, this number of proton minus this, not minus, this will be the addition, because 2 negative charge means 2 electrons are added here. So 34 plus 2 will give you the 36 electrons, and the number of neutron is again very easy. The mass number minus the atomic number, this will give you here 78 minus 34 will give you the number of neutron, 44. So now come to the actual exercise here. In this exercise 2.1, we are asked to calculate number of proton, neutron and electron in the one isotope of sodium. You see here the atomic number in both the cases are same, but the mass number are different, means the number of neutron will be different in this case. So atomic number is 11 in the part A. So this 11 will give you the same exactly number of proton, and the atomic number are same thing. Okay, and the number of electron, because the charge here is 0, no charge means the number of proton and the number of electrons are exactly equal. So this is the same answer, 11 electron, electrons will be here, 11 electron, and this is not number of neutron. You can calculate by mass number is 20 minus number of atomic number or number of proton, that will be equal to 9. So similarly you can calculate here, no charge is there, so proton will be equal to the electron, and you can calculate proton, neutron and electron. Here in this part C, you will see it look like the question is not complete, mass number, atomic number is missing. So here you have to see in the periodic table, the atomic number of the oxygen is 8. From the periodic table you have to see and write here, and then you can calculate proton, neutron and electron, very easy. This part D, this is the isotope of carbon 14. So carbon 14 means this is the symbol of carbon C, and 14 is the mass number, so you write here 14 is the mass number, the same. And actually the average mass number in the periodic table you will see 12, but in this question they are selecting a particular isotopes, that is carbon 14. So mass number will be 14 here, and when you see in the periodic table the atomic number is 6, so you write here 6, the atomic number will be 6, this is the number of proton. So now you can calculate here number of proton is equal to 6, number of neutron will be equal to 14 minus 6, and number of electron, because there is no charge, so it will be also equal to 6. Okay, so you have to solve this exercise by your hand. If you solve it by yourself, you understand more. In the practice exercise they are giving carbon 63 atom and asking you calculate the proton, neutron and electron. So here again you will see the atomic number is missing, so you have to see in the periodic table, you will see there in the periodic table the mass number of copper is 29. Let me show you, we are near this periodic table. You see this is copper here, the atomic number is 29. So you can write here atomic number is 29, and this 29 means the mass number, atomic number and the number of proton is equal, so you can write 29 here, and neutron will be equal to 63 minus 29, that will give you the number of neutron, the 29, this is wrong here, 29, and number of electron will be equal to number of proton, because there is no charge, so number of electron is same, 29. So this is the end of our lesson 1, and we will see you in the lesson number 2.